Children who develop the visual impairment, often called lazy eye, can be treated by covering their other eye with a patch. Now, researchers think they have found a way to treat adults using a toxin found in deadly pufferfish. The approach has only been tried in animals so far, but NPR's John Hamilton reports the results are encouraging.
A lazy eye isn't really lazy. The term refers to amblyopia, a medical condition that occurs when the brain starts ignoring the signals from one eye. Existing treatments restrict use of the strong eye in order to force the brain to pay attention to the weak one. But Mark Baer, a neuroscientist at MIT, says that approach has limits.
There are a very significant number of adults with amblyopia where the treatment either didn't work or it was initiated too late.
After a critical period that ends at about age 10, the connections between eye and brain become less malleable. They lose what scientists call plasticity. So for several decades, Baer and a team of researchers have been trying to answer a question.
How can we rejuvenate these connections? How can they be brought back online?
To find out, Baer's team studied adults with amblyopia who lost their strong eye to a disease or an injury.
Unexpectedly, in many cases, vision recovered in the amblyopic eye, showing that plasticity could be restored even in the adult.
So the team did an experiment with mice and cats. They injected an animal's good eye with the paralyzing nerve toxin found in fugu, a type of pufferfish. The toxin is so powerful that fugu sashimi can be lethal if prepared incorrectly. But Baer says when a tiny amount is injected into an eye, it blocks all communication with the brain.
So we simulate loss of the eye, but only temporarily, only for a matter of a day or two.
Baer says that's enough to set the stage for rapid change in the brain's wiring.
The brain is now in a mode where it's seeking input. And it's as if you've turned back the clock to a period of early development.
When the toxin wears off, the brain begins making new connections with the amblyopic eye and the animal's vision improves. The finding, published in the journal eLife, is the latest evidence that amblyopia can be corrected in adults. The next step will be to test the approach in primates. In the meantime, scientists are trying other tactics to treat amblyopia in adult brains. Stephen Greco is part of a team at the University of California, Irvine that has done experiments using the drug ketamine.
Mice that were treated with ketamine, the vision in their amblyopic eye had improved very significantly, and we were able to see that with behavioral testing of visual performance.
The treated mice spotted a visual target that the other mice couldn't see. Greco says ketamine probably worked because it induces brain plasticity. Jennifer Raymond, a neurobiologist at Stanford University, says all of this research shows that adult brains can rewire if pushed.
I learned to surf a couple of weeks ago at an age where I thought maybe it was too late. I did learn, but not as fast as my teenagers.
Raymond says that makes sense because an adult brain emphasizes retaining old skills over mastering new ones. Even so, she says, studies of adults who've had a stroke show that the brain retains a remarkable ability to change when it needs to.
Often patients can recover a lot of function, whether it's movement, whether it's reading. But a key question that labs like mine are asking is, how do we better enhance that plasticity?
Raymond says answering that question could change education, rehabilitation, and the treatment of brain disorders. John Hamilton, NPR News.